Okay, I'm just gonna get going. Wanted to show you guys a little bit of our agenda for the day. We are going to do a quick introduction to Comport. Then we're going to move on to the bulk of our webinar, using AI successfully in business, and then we'll open it up to the Q&A. I want to introduce our speakers for the day. The first speaker is going to be Erik Krucker. He is our CTO for Comport, and he manages our IT solution portfolio and strategies. His prior experience includes responsibility for Weill Cornell's Medical College critical systems, including virtualized email, Epic EHR, and storage. He also led a storage team for a global service provider on mission critical IT services, including cloud computing and infrastructure as a service. Our next speaker is going to be Frederic Van Haren. Frederic comes from HighFens. He is the CTO there and founder. HighFens is a leading AI consultancy serving enterprises and AI vendors. Prior to HighFens, Frederic spent more than a decade at Nuance Communications, developing their speech recognition engine used for Siri, among other noteworthy technologies. His projects also include multiple large HPC and AI environments built from the ground up. With that, I'm going to give it over to Frederic. Frederic, do you want to take it away?
So today we're going to talk a little bit about AI, and more specifically generative AI. And then after that, we're going to talk a little bit about some use cases around generative AI, see how enterprises are using generative AI, and why it's useful for enterprises to actually participate in generative AI. And then finally, we're going to talk about the unavoidable infrastructure, right? So what are people using? What should they be looking for? And some guidelines around what technologies are appropriate for generative AI. So we already did the introduction. So AI and generative AI. And so the easiest way to kind of get going is to kind of explain a little bit where all the terminology is coming from. Most people probably already have a good understanding of this, but it's always good to come up with a good baseline. And so the way it works is that deep learning is really the very popular technology today that people are using, is a subset of machine learning. And so sometimes it can be confusing when people talk about machine learning, that it kind of includes deep learning and so on. But nevertheless, we're going to try to kind of dissect this a little bit so that everybody has kind of an understanding of the same baseline. And then machine learning is a subset of what we call more traditional AI. So really, what are the differences? And so in the early days of AI, surprisingly, data was not the input. Data was more used for testing purposes. Everything had to be coded. And so in the early days, coding was the main goal and data was used for testing. So what's then machine learning? Well, machine learning is really the ability to learn without being explicitly programmed. So really, what does that mean? It really means that now that we have access to data, we kind of trying to integrate data into our process and have the data kind of decide some of the decisions that have to be made. And if you then look and compare that with deep learning is where there's almost no data, everything is all about the data. There's almost no programming going on in the background. So why not always use deep learning, for example? Well, the challenge with that is you need a lot of data for that and a lot of processing power. And in some cases, you don't have the processing power, or you don't have all the data, or you don't have the financial means in order to do deep learning. So it's kind of a middle of the road trying to figure out when to apply machine learning and when to apply deep learning. So, if we then go and look a little bit at what organizations really are looking for when they participate in AI, is it's really a full cycle or end-to-end operation. And so the two main components that people look at is one is training. So the training phase is where you take all of your data and you try to build a model out of it. And that model is kind of representation of all the data you have. And the inference piece or the development piece is really where you deploy that particular model. Deployment sometimes is also used inference. And so the reason why end-to-end is really important is because you want to have a pipeline, if you wish, from the moment the engineer is working on their desktop all the way to analyzing that data on premises or in the public cloud, and then deploying. And the deploying can also be on premises in the public cloud or even at the edge or an IoT device. And so that's the theory. The reality is that the inference actually overlaps a little with training. And the reason for that is every time you do some inference, you get some new data. And that new data contains new values and new information. And what you really want is you want to change or adapt your model such that the new data is being incorporated. And so that's kind of the native approach to AI, is that you continuously learn. For every time you try to do an inference, you learn something new, and those new learnings in a way of data goes back into the training mode and you update your model. And so that basically means that with AI, you're never done. You're always in a mode where you improve your model, being it with new data or more data or new algorithms. And so this is really a key factor, because AI compared to more traditional IT is, with traditional IT, you have a finite solution where you version 1 and version 2 and so on. With AI, it never ends, so to speak. And so that's really a key piece. So let's talk a little bit about the challenges around training.
Hey,
And
Frederic,
so,
real quick question for you. So
yep.
in the life cycle of AI pertaining to, I think it's 2 slides ago, you don't have to go back, but just uh what is usually, is there a particular starting point that most organizations begin at, and then what does that journey usually look like for them, typically, or do they just jump right into deep learning?
Right. No, definitely not jumping straight into deep learning. So the math behind AI is statistics. And so that means that out of the gate, you have no idea what's going to work or what's not going to work. And so traditionally, what you try to do is you come up with a subset of your data, could be on a desktop or could be something in the public cloud, and you come up with a POC. And basically what you're trying to do is throw stuff at the wall and see what sticks, right? And as you go along, you improve your model, and at some point you will reach a level of usability, which is performance, time to market, and accuracy. And at that point, you can start thinking about scaling. But even when you scale, as I explained in my previous slide, you get more data. So it's kind of exponential, right? And that brings us to this particular slide,
So you have
which
lots
is
of data, you train, it generates more data, you feed that data back into your model, and it just grows and grows and grows typically.
exactly, yeah. And if you look at, what Gardner and other people are saying as far as data being generated, out of AI or IoT devices, people are saying that it's going to double every 3 years. So if a customer today is using AI with, let's say, a petabyte of data, the likelihoods that they will use or have 2 petabytes in 3 years is quite significant. Now, the problem there is if you double the amount of data, you could also assume that the amount of time it takes to build your model is going to be twice as much. And that's kind of going against innovation, right? Innovation is saying that you should get faster, better results in less time, not in more time. And then the second problem is that the algorithms that are being used to analyze the data, which is typically kind of explained as in a certain amount of parameter. So a parameter is an unknown that has to be solved. And the amount of parameters, referred to as a complexity, is doubling or times 10 every year. So if you combine both of them, that basically means that somebody who's successfully doing AI not only will get more data, which is going to take longer, but they're also going to need more hardware in order to analyze the data. And that is really, really challenging for people to stay relevant because it forces people to grow their environment much faster than a traditional IT environment. If we look at the challenges around production is really, it comes back to the end-to-end approach, right? You want to be able to go from training to inference and back and forth and optimize and introduce new innovation as you go along. The reality is it's easier said than done. And there's a couple of reasons for that, right? Data complexity. It's easy to say, I'm going to double the amount of data, but you have to store that data. You have to process that data. You have to figure out if that data is proper quality. Maybe those data sets rely on different storage devices. So all of that complexity together with lack of the right infrastructure, and sometimes the lack of infrastructure is not that there's no infrastructure around, it's just that it costs a significant amount of money to buy that infrastructure, right? Which basically means that if you cannot buy the right infrastructure, you're going to have difficulties deploying this in a proper way. And then obviously there are the skills, right? AI is very much in demand today. So all of the resources regarding to AI are being absorbed by typically the major players. So how do you solve this, right? Well, you can protect yourself a little bit against some of those problems. First of all, you can heavily invest in data management. Data management is basically what we used to call storage in the past, right? Storing the data is not enough. You have to manage that data. You have to have the ability to move it around. So data management tools is a good investment. AI tools and frameworks, there are a lot of options regarding to tools. Finding the one that is appropriate for your workloads and for your AI problems is really key. Making the bad decision there is gonna make sure that you're not gonna be very successful in production. And then accelerated infrastructure. Typically, I would say GPUs, but the GPU is not the only one that can accelerate a workload. And so this brings us to generative AI. So everything we said so far is AI in general terms. There is machine learning, there is deep learning. What is generative AI? So generative AI is a specific subset of deep learning. What that means is there's a lot of data involved, there's a lot of complexity involved, but generative AI is using existing content, being pictures, text, audio, video, and so on, to create new content. So you can look at generative AI as a tool that helps you being creative, right? If you're not very creative, generative AI will help you with that. And so when you look a little bit closer at the complexity of generative AI, I mentioned before, a complex solution is being referred to as parameters in the billion. Everybody is pretty much familiar with GPT and ChatGPT nowadays. If you look in 2018, they're barely, 0.12 billion parameters. If you look at 2023 today, that is 1,800 billion parameters. And so the way you can look at this is that analyzing data and solving unknowns like parameters, it is not a linear equation, it's exponential. And so this means that generative AI relies on a massive amount of compute power. And just to give you an idea, is ChatGPT 4 was built with 25,000 GPUs for about 90 days. If you only had one GPU, that would take you about 6,000 years in order to build a large language model like ChatGPT 4. So that's pretty significant, right? So this is one of the reasons why in the world we live in today, a lot of people are talking about GPUs, accelerating, faster, lower latency. All of these components are important because nobody is sitting around and waiting 6,000 years for a large language model. So now that we talked a little bit about generative AI from a theoretical principle, what does that really mean to people? So the reality is that building these ChatGPT models, which we call base models, is not everybody can do that, right? If it takes 25,000 GPUs to build a large language model, you can assume that in the world we live in today, there's probably a handful of organizations who can build those large language models, right? So no surprise, we have Google with Gemini, we have Meta with Llama, and then we have OpenAI with ChatGPT. And so those organizations, what they do is they take all the data they have lying around from open source, from all kind of different sources, and they will spend the money, the 25,000 GPUs, in order to build this large language model. And so that's what we call a pre-trained model or a base model. And some of them are open source. For example, Google and Meta deliver large language models that are open source, while OpenAI, for example, is charging for the usage of their large language models. And so the reason why this is key is the second step. It's the customizing a pre-trained model. So anybody can download a large language model from, let's say, Llama from Meta, and then add some more domain-specific knowledge, right? So for example, a large language model today from Meta does not include a lot of information about legal or medical terminology. If you're a hospital, what you would like to do is to start with a base model from Meta, being Llama, and then add more domain-specific data. And so there are a couple of ways to do that. The most straightforward, but also the most insane, is to say, I'm going to rebuild the whole thing. So basically introducing your specific domain data and retrain the model with 25,000 GPUs. Most likely not going to happen. The second best thing is to take a subset of your domain-specific data and then slightly retrain the large language model to include your domain-specific data. And then so once you have that, you have now your own customized model that you can use in your own enterprise that includes the domain-specific data. And then from there on, there's the final stage, which is the generation, where that model, that customized model you just created, that's being deployed and can generate text, video, audio, or images. So it's probably a good idea to explain one of the more popular ways to take a large language model and inject your domain-specific data. It's something that is typically referred to as RAG, which stands for Retrieval Augmented Generation. So how does that work? So you start out with a custom large language model or a base model, which does not have your specific domain data. And you then create a knowledge base that includes your specific domain data. And so the way it works is a little bit technical, but let's kind of dissect it a little bit. So the knowledge base is really what they call a vector database. So we all know what a database is. A database is just rows of data. They all look the same, but the data is different. And what's a vector? Well, a vector is really a way to convert something that is not a number into numbers. And so embeddings is a series of vectors, and embeddings, you can look at that as a translation of text, let's say, in numbers. So you remember I talked a little bit about AI being all about statistics. Internally into an AI engine, it's all about numbers. So everything has to be translated into numbers. And so embeddings are what those numbers are. So if you have your specific domain data, you convert that and add that into a vector database. Once you have your vector database, you have the ability to apply RAG. So the way it works is, let's use an example. Let's assume I get a specific domain question, and it might sound something like, how many of our products has customer A purchased in the last 6 months? So the base large language model understands all the words in there. However, there's some specific data in there. For example, our products. What is our, who are we? What is our company? And then there's also a reference to a customer A. Who is customer A? What's the details? And then there is also about some specific requirements regarding to the last 6 months. Now, if all that information is in your knowledge base, then this particular prompt will be augmented with our information. So you start out with the prompt. The prompt goes to the retriever, which is a process. And the retriever is then going to look into the knowledge base for the closest match. And then once it finds information regarding to our products and customer A and whatever the customer A has done in the last 6 months, then the prompt will be augmented with that information. And then that augmented prompt is then going to be sent to the base large language model, who will then generate an answer based on the augmented prompt. So this is an example on how you can introduce domain-specific data into a base large language model. One of the reasons why RAG is really popular is you don't have to retrain the custom large language model. Retraining is a very expensive event, while RAG seems to be a easier and better and more flexible way to do this. All right, so now it's time to talk a little bit about generative AI use cases. Where is it being used? How is it being used? A few months ago, I went to the NVIDIA GTC conference. So NVIDIA is a supplier of what we call GPUs. So this is a very popular piece of hardware that is being used to accelerate and is kind of a requirement in order to build large language models. And at that conference, there were a few companies talking a little bit about their experience with generative AI and what kind of use cases they were using it for. So there are three sessions that I particularly liked. The first one is about cosmetics from the L'Oreal group. The second one is from the Ford company. And then the last one was a session by NVIDIA on the advantages of generative AI in pharma and life sciences. Just to be complete, I also provided a QR code to those sessions. Those sessions about half an hour to an hour. You will have to register, but there's a lot of good information in there. Even although I'm talking about Fortune 500 companies, there is no need to be a Fortune 500 companies to do generative AI. It's just that those examples are much easier to explain. So let me go through each one of them from a high level. If you look at generative use cases across the board, so we talked a little about text and speech. So we're all familiar with the existing ChatGPT being relatively good at summarizing translating, but there are still other use cases that are being worked on. So you can expect that newer versions of ChatGPT and Llama and Gemini will have a better way to address the generative AI use cases that are being worked on. But it's interesting to show all the different areas where the innovation is happening, even in coding, right? A lot of people are talking about code generation. There's pluses and minuses about that, but it's making a decent amount of progress. Does that mean that we are not going to have programmers in the future? That is not what this is saying. This is basically saying that generative AI is a tool that helps you create in whatever you're trying to do. And then image and video, a lot of interesting things are happening on the imaging side. People are familiar with Adobe Photoshop. With Adobe Photoshop, you can modify pictures. However, all of the modifications have to be done manually. While there's a new product from Adobe called Adobe Firefly, which is all based on generative AI. So instead of saying, I'm going to draw an elephant on the picture, you can basically say, please draw an elephant, and the elephant will be drawn on the picture. And so this is a great example of generative AI being used in the imaging and video world. And then there's a lot of tabular data. We all think in spreadsheets, so it's important that we can handle spreadsheets, analyze spreadsheets in a very easy manner. Plenty of generative AI use cases. So let's talk a little bit about what L'Oreal Group is doing regarding to generative AI. And again, this is based on their presentation. And so the presentation was heavily focused on generative AI for marketing purposes. So one of the challenges that a company like L'Oreal has is when they want to come out with a new marketing or advertisement, they have to hire expensive models. They have to put them all in the same room. They have to have pictures, high-resolution pictures. There's a lot of work that needs to be done to get it done. And so L'Oreal created a lab, a content lab, where they don't need the models to be physically in the room. Now they can create marketing material based on the generation of models that don't exist, but is based on a model. Customer care, a lot of organizations are using generative AI as a virtual assistant. A virtual assistant doesn't sleep. It's easy to update the information, and it helps a lot with customer care. People having questions and so on. Services, there's a lot of services that are being provided by the cosmetic market. Their biggest challenge is that they can't update their service portfolio fast enough. So they're using generative AI to help them improve and accelerate this. And then finally, they want people to use their phones as a way to get fast access to new products, marketing material, Q&A questions, and interactions with support. So there's a lot of going on at L'Oreal, and it's interesting to see that even a retail group like L'Oreal that really doesn't do a lot with technology is now using a lot of the generative AI technology in order to improve their products and access to customers. Next one is Ford. Ford has been using generative AI for a long time.
Frederic,
Yes?
we have a quick question. Does AI create fake models in the content lab? That is, does it ask the real models if their images can be used?
Yes. Yes, definitely. I mean, they're still rely on their models. It's just that they don't need their models to be available during the photo shoot. They have contracts now where they take pictures ahead of time, a lot of data. And so it's still the same thing. The models are still involved. However, they're not involved at the time of the shooting because everything is happening electronically. So this is a solution where the model is not being eliminated. It's just that they're being introduced at a different time. All right, so Ford is using generative AI across the board. And so Ford was talking a little bit about three scenarios or three possible scenarios where they were using generative AI. However, anything Ford does with generative AI, they have rules they have to apply to. So a lot of people have heard that large language models can hallucinate. So it's really code for saying you ask a question to the large language model, and the large language model does not know the answer, but still gives you an answer, which is wrong. And so Ford has certain guidelines and guardrails for generative AI. And so one of the two guardrails they have implemented is if the large language model does not have the exact answer, then no answer will be provided. So they're trying to eliminate the hallucinations. The second problem they're trying to address is data lineage. So when you use a large language model, you have no idea where that data came from. And so data lineage is a way to say, I need to know where all that data is coming from that was used in this large language model. And so Ford is saying that each answer will have the sources cited. So in other words, every time you ask the generative AI engine at Ford a question, it will also tell you where it found the data with a reference. You can validate and check the answers if you want. The three areas where they're using generative AI is, first of all, the owner's manual. So Ford is still making and building or creating those large owner's manuals, but they're fully aware that nobody's reading them, right? So they're trying to displace that by providing a generative AI engine that has all the information from the owner's manual and where you can ask questions and where it will return you with the right information, being textual with pictures and tables and all that stuff. It just gives you all the information in a single shot. The second generative AI appliance they have is the workshop manual. And one of the reasons they have done this is they have detailed instructions how to disassemble a part of the car. However, the instructions in the last page always says for the reassembly, do everything in reverse. And so it's easier said than done. With generative AI, they can actually generate specific tasks on how to reassemble a part when it has been disassembled. So instead of saying just do the reverse, they now explicitly give the instructions on how to do this. With the cars being more and more complex as far as electronics and mechanical devices, this is really a great welcome for technicians that are working on cars for Ford. And then finally, they have a contact center, so they get about 15,000 calls a day. And so they use a combination of AI and generative AI. And so for each call that comes in, they transcribe the call. So it's typically a voicemail. They transcribe it, meaning you go from a voicemail to text. Then the second step where they use AI is to de-identify. So if a question needs to be answered, the technician doesn't need to know who called, what the phone number is, and so on. So they de-identify, so removing all personal information. And then they use generative AI to summarize. And then finally, they use generative AI to generate an answer. So that's Ford. Next one up is NVIDIA's view on life sciences. So what NVIDIA has done is they have been working with a lot of startups in the pharma and life science market. And so for each one of them, they have found an improvement over the non-generative AI process. So for example, for drug molecular design, so this is the enhancing the discovery and optimizing of drug design. So there's an overall 25% time reduction in design. There's a lot of research going on in life sciences and pharma. This is really expensive. So for them to be able to reduce the amount of time it takes to come out with a new design is very key. A few others, clinical development, where they're using automation of documentation, quality control, where they have a 20 to 30% productivity improvement. Content creation, which is kind of a very popular generative AI use case across all markets. And then a review process, for example, where they can gain up to 40% of productivity. It's interesting to see that a hardware company like NVIDIA is sticking its nose into the processes on how all those verticals are applying generative AI. And that simply indicates that the software drives the hardware. So we'll talk a little bit later in the presentation about that, but it's definitely a key factor. Some data points, again, from NVIDIA. So 58% of the pharma companies do realize that generative AI is really important to them. 42% already has a budget for it. And the expectation is that after 3 years, there's a 9% operational efficiency. Again, it's pharma, life sciences. There's a lot of money behind it. You can see it, 2032, the market size will be almost $25 billion. So 9% of $25 billion. It's a lot of money saved and time. So stepping away from the use cases, let's talk a little bit about infrastructure. Some people have a tendency to say that AI is about buying GPUs, and in some cases it's true. However, it is really your workload. Your workload is what the problem you're trying to solve, which actually will dictate what kind of infrastructure you're going to need. And so your workload would typically depends on what industry you are, what type of AI you're trying to apply, how complex are the algorithms, what is your typical data profile? Do you have billions of files or millions of files? Do you have small files or large files? All of these items are part of a workload definition, and that workload will define what the next step is going to be. So what's a software framework? Software framework are the algorithms that are required in order to analyze that data. There are many, many, many software frameworks. Some of the frameworks work with GPUs, other frameworks with CPUs, other work with CPUs and GPUs. Others might rely on FPGAs. So it is important to understand the software framework. The software framework will also dictate what your compute will look like, right? So if you're doing generative AI, large language models, and you're doing retraining, then your software framework will most likely direct you towards like an accelerator, like a GPU. Once you have a good understanding of what kind of compute you need, then you need to look at your storage solution. And so the storage solution basically consists of delivering the data fast enough to your compute. Compute is very, very expensive. So you want to make sure that your compute is never idle, that there's always enough data for your compute to analyze the data. And then finally, the network. The network is the bridge between your compute and your storage. Typically, network is not a single network. Typically, you have multiple networks. You have a compute network, you have a storage network, you have an out-of-band network. All of those networks are optimized such that they can make sure that the data gets delivered to the compute fast enough and that the data can be analyzed in a timely fashion.
Frederic, so quick question. Typically what I see a lot of organizations do, to your comment earlier, is they take this sort of dip their toe into the water approach to this problem or this opportunity. And they will, start with their software stack and try to figure things out. Maybe they start on their laptop and then they kind of migrate that into a larger to try to scale things out. And most organizations, what I see is that they don't make this huge investment right up front, and they buy all new compute and all new storage and all new networking. And so they take and they try to cobble together some of what they have already in the enterprise in order to satisfy the needs, and they think that that's going to be able to work in the short term and then in the long term as well, which I see as a huge challenge because they're not making um, all the proper investments, or they're not making them at the right times, and then they're getting poor performance. And then maybe secondarily, the other path that I see is I see people going out into the cloud and starting out in the cloud, and that has other challenges, particularly around financial challenges. So maybe talk about those two things and kind of where you see those challenges and what you're seeing in the
Right. So
marketplace.
starting with the public cloud. So the public cloud is really popular when you're POCing, when you're trying to figure out what you want. And the reason why the public cloud is interesting is the public cloud has different types of accelerators and different types of technology. So you can try in the public cloud all your different types of hardware, your different types of solutions and approaches to the point where you end up with something that guides you in the right direction. And to your point, anything you run 24/7 in a public cloud is going to cost you a lot more than on premises. And so this is one of the reasons why a lot of organizations that buy a lot of GPUs or require a lot of GPUs have a tendency to buy the GPUs on premises, because if they deploy that in the public cloud 24/7, they will pay that same GPU over and over and over. That doesn't mean that the public cloud is not a right solution. It's just that for scaling and 24/7, I would say that's the public cloud might be not that cost effective. And then your first question regarding technology, if you buy the latest and greatest GPU, from an example from NVIDIA, you need to buy along with it a server that is very recent, right? If you try to put a brand new GPU in a 2-year-old server, you're basically wasting money, right? That GPU will probably fit in the server and will power up. However, that server might not feed the data fast enough to your GPUs, and at that point, you have a really, really bad ROI. And so infrastructure has a tendency to expire a lot faster in AI than in traditional IT. So if you look at NVIDIA coming out with a new GPU every 2 years, and most people have a tendency to keep their hardware for 3 to 5 years from a depreciation standpoint. I mean, there are choices to be made, right? And by the way, that new GPU card that comes out every 2 years has typically twice the performance capabilities of the previous version. So there's a lot of challenges there to deal with, but it's definitely different than more traditional IT. So when we we are used to CPUs, right? To use CPUs everywhere, laptop servers and so on, and the CPU is still great, but the CPU is really great at low latency and serial processing. The CPU isn't that great for parallel processing and high throughput. So you need to go to accelerators. And again, I'm always kind of mentioning GPU, but the GPU is not the only game in town, right? So acceleration depends really on what your workload is doing. And so the two main factors why the GPU or an accelerator is really key is the data growth and the complexity. It's very, very difficult to keep CPUs scaling at that level. You need GPUs in order to do that. And so maybe a better way to kind of look at the hardware choices is in this case, I have here listed a data pipeline where you start with ingesting the data, and then after the ingestion of the data, you have to prepare the data and transform the data. And then you enter the heavy duty training phase. And then after the training phase, you want to validate that your model is on par with what you expect. And if then you go into the inference phase. So what are the IO profiles in that case? So for the first two, you're really talking about sequential data, right? It's sequential data processing, and while in the training, it's very random. And so that gets us to the next point is that ingestion, as you can suspect, is sequential and 100% right? So you're absorbing the data from an outside source. And then as far as the preparation and the training goes, you take that data and you read that data over and over and over, with a little bit of writing, but mostly all reading. And then in validation and inference, that's even closer to 100% read, right? So you're really trying to focus there on using the models as trying to change the models. So people always ask us, should I buy a storage solution that is POSIX-based? Do I need to buy objects? Can I use Windows? Reality is there's an approach for each different phase into the data pipeline. And this is an example. This doesn't mean that you have to use GPU direct, for example, in the ingestion. It just means that in a traditional, if there is such a thing as a traditional AI workload or AI data pipeline, you will see NFS very, very much used in a preparation or ETL, and then maybe some POSIX on the training side, and then for validation you might use object, and then once you deploy your model, it might be deployed in a Windows environment. Now, all of these storage approaches, they don't come from a single storage device. Those are multiple storage devices, and this is where data management comes into play, right? It's great to have a very fast and usable POSIX solution, but how do you go from NFS to POSIX, right? That data needs to be moved or copied, and so data management becomes more of a factor than anything else. And then finally, do you always have to use GPUs? I guess you can, but when you do data moves at the ingestion phase and the preparation phase, CPUs are still the best way to work. You know, there's no reason to push all the data to GPUs just in order to move or copy that data. And so the point here is that there is a technology that is appropriate for every phase in a workload. You just have to figure out what that means for you and your workload, and making sure that you apply the right technology for that. So that's on the hardware side. So what does the software side look like? Well, it's actually worse than the hardware, I guess. So you could look at the software stack as tools or frameworks you need to handle the data. Then you have tools you need or frameworks for training, and then for inference. And so if you look at the data, you know, there are some tools that you need to use for processing, for pipelines, versioning, data sources. It actually doesn't make a lot of sense to go over all of them one by one. The reality is this picture might be outdated in a month with something else. And so this is kind of the innovation behind generative AI. It goes so fast that you have to look around and keep on innovating. If you don't, you will be left behind. So this is different than 10 years ago. So 10 years ago, when I was looking at AI, we had to build all of this ourselves. There were no options. I guess today we have the opposite. We have so many choices that it's a little bit too overwhelming.
And
So
this is just a
this
small
is
sample size. This is just a fraction of the possible tools that are out there as well.
exactly, yes. Yes, yes. There are slides I can show you where you can't even read the name of the tools, and so,
Right.
but it just proves how much innovation is going on, and also the fact that certain of these products will be obsolete in a year or two. Right. That's another thing you will see with AI is a lot of the frameworks will become obsolete because new innovation will have replaced um, one of the frameworks. So this brings me to the end of the three parts. We do AI solutions and services. The easiest way to kind of explain what people are looking for is when we talk about consulting and services, a lot of organizations are coming to us and saying, hey, I don't know anything about AI, or I'm a mature organization about AI. What's my next step? How do we do the following? How do we implement a roadmap for the next coming years? We provide services, hands-on, and so on. Data management is really, really important one for mature AI organizations. Data management is the number one item. And then also a lot of engineering work regarding to automation. And then finally, AI solutions. So what are AI solutions? It's where the customer is saying, right, design a complete solution, an end-to-end solution that scales with a roadmap. So that includes design, building, high performance tuning, and so on. It is no customer is the same, so there is no way for us to say this is the way to do it or not the way to do it. Everybody does it differently. Everybody has different goals, but they all are looking for similar things: is to be successful in the AI market with a good return on investment. And then finally, this is where we can reach out uh, and have conversations with us. QR code is available. I think I went way over time, so hopefully there's some questions that I can answer that haven't been answered yet.
One other before we get to there is a question before we get to that though. I want to say that one other challenge that I see with a lot of organizations is that they get into this process and they're going through maybe the proper methodology and they get to the the top, we're taking a top down approach here, right, where it's consulting, listening to the business needs, talking about the software frameworks. Eventually you'll get to the pipe, the plumbing, right, what actually does all the processing, where it's stored, how it's stored, all those things. And power and cooling is a huge challenge for a lot of clients because the power requirements are just growing and growing exponentially, it seems, every single year. And then data center space is a big issue for customers as well, which kind of goes hand in hand with the power and cooling issue that comes along with GPUs and higher processing, accelerated processing, and things like that, which is one of the areas where we can help out and do the consulting work to figure out, where does that data need to be from a locality perspective. We have our own data centers where we can house a lot of this data, and then we can sort of build best practices approaches to building out the infrastructure and helping customers figure out how to do that.
Right. I mean, definitely power and data center space is becoming a problem because the amount of power you need in order to feed those GPUs, it's massive, right? I mean, there was a time where you could physically fill a rack and not consume all the power for that particular rack. Now, with a rack maybe half full, and you already have consumed all your power, and that's generating a tremendous amount of heat. Yeah, so those designs are really key. The last thing you want is to have a data center that is overheating.
Yeah.
All right, so
We're-
Frederic, there is a question. Someone is asking, is one of the primary reasons for AI projects to fail that end users have very high expectations and the level set has not happened? In our company, I come across use cases where instead of looking at AI projects as a constant evolving and incremental step in the right direction, users feel that from get-go, AI should alleviate their issues on day one. I'm interested to hear your thoughts on this.
Yeah, this is an FAQ, right? AI is about trial and error. First time right doesn't exist, and the reason for that is because AI is driven by data, and so the likelihood that you have the right data from day one is very unlikely, and also the fact that you have the right software frameworks and the right infrastructure in place, and so it's very unlikely. So I totally agree the fact that it's extremely unreasonable for people to have high expectations. And by the way, AI has not always been successful. AI has had over the last 100 years two winters, as they call it, meaning it's an area where there was demand for some kind of AI, but then it kind of cooled down. And in both cases, the expectations were way too high for AI, and so it cooled down to the point where we had to do a reset. I think it's important for everybody to understand that AI, it's trial and error. Anybody who expects great results from day one is maybe a little bit naive. I've never seen anybody saying success from day one.
I mean, even IBM had issues with Watson, right? So they kind of, I don't want to say abandoned that project, but kind of shifted how they were approaching Watson and what they were doing with it. And they have massive resources, right? So, yeah.
Great, thank you. If anyone else has any other questions, please put them in the chat and send them over to us. I don't see any in the moment, but we will give it a few minutes.
I think we saw one more question regarding to AI for students. I think generative AI is a creative tool, right? So students today are not expected to repeat and parrot back all of the things they learned in high school and college. I think people are now expecting the new generation of engineers and students to be more creative. And I look at generative AI and AI in general as a tool to help people be more creative as opposed to parrot back whatever they have learned in the past.
Yeah.
Thank you,
One other
Frederic.
question.
Well,
One other
go ahead,
question.
Erik.
Yeah, really quickly is, the sort of buy versus build mentality in the sense of, let's take healthcare for example. And what I see in healthcare a lot of times is organizations waiting for somebody to put together an integrated software platform that will do things like their radiology system, which is a big use case right now. So instead of them building it themselves, right, based upon computer vision, right, they're relying on somebody else to build it for them. Do you see sort of a lot of that happening in the marketplace versus like building, organizations building it themselves? Is it more of a, it really depends kind of, where you are in the life cycle, or how do you see that playing out?
Yeah, I think it's interesting. It's an interesting question because if you look at a company like NVIDIA, who most people think as a hardware company, it is actually a company that is trying to address exactly this problem, where they're actually going to all of those organizations and saying, hey, sure, we can sell you GPUs, but we really would like to understand what are the different phases and the different components you need in order to be successful. So NVIDIA has helped, as a hardware company, has helped a lot of companies understand the different phases and what they need to do in order to be successful in AI. I do think that unless you do something that somebody else already has done, that the recycling and using some software frameworks will help. Like for example, cryo-EM, right? That's I think a vertical where there's a lot has been written. There are reference systems. So there, I'm pretty sure you can find a way to get started based on existing reference systems. If you're trying something completely new, you're basically going off the road. You have to try things on your own and maybe write your own algorithms, right? So I go way, way, way back on AI. And so in the speech world, there was no existing AI framework. So we have to build our own. The crazy thing is something it took us 5 years to build. You can now download it and use it, and you can have your own speech recognition engine in 5 minutes. That took us 5 years with 800 engineers.
Right.
That's very interesting how AI is evolving and how quickly you can implement things that previously were not available. So, all right. Well, I don't think there's any other questions. If you guys need any help, reach out to us here at Comport or reach out to Frederic as well. Um, I think with that, we'll end the webinar today and have a good day.
Thank you.